Here we can do a few things. We can convert this to rational exponents and this to rational exponents and then apply the power. So I'm going to apply the exponent like this. A has a power 1, it's root 3. B, the power is 2, the root is 3. This is all connected by times. So I'm first going to just apply the power first. Let's get rid of that. So power 9, power 3. Okay, we apply the exponent. And since powers and roots are the same, it doesn't matter if we do the root first or the power first. So now I'm going to apply the root, a to the root 2 power 9, b to the power 3 root 2. Okay, so we have our roots in the denominator, that's a square root, so it becomes a 1/2. So now we can put the a's together. Because the a's are the same base, we can apply exponent rules, but we have to then add exponents, add the powers with different bases, which means we need to get a common denominator. Or in other words, we need a common root or a common index. And that we could also have done that with the roots, but it's much easier as an exponent. Okay, so I'm going to group that. And then I'm going to group, and that comes from my A and A. It's all multiplication, so we can group that all together. I have my B's and B's, so I'm going to group all my B's together. So I end up with B. It's all multiplication, so I can add the exponents. I have 2/3 plus 3/2. Okay, so again here I'm adding exponents of different, I'm adding fractions with different denominators. We need to get a common denominator, or in other words, a common root or common index. So I'm going to move that up here. So this becomes a to the power, common denominator 6. So we're going to end up with 2/6 plus 27/6. Okay, and then we're going to have b to the power, common denominator 6. So it's 4/6 plus 9/6. Okay, and then my final step is I'm going to add those together. I get a to the power 29/6. Okay, and then I end up with b to the power 13/6. Okay, so there's my final answer here. Now I could have done this with a common index of 6 as well, and that would have allowed us to combine these roots together. So here we can rewrite this as a to the power 5, b to the power 6, and we can do the first embedded square root as a power. So I'm going to do this in colors here. So that's going to become power 1/2, and then the outside power, cube root, or outside root, I'm going to write as a 1/3 root. Okay, and I can actually combine those together, because if I do a cube root and a square root together, I can just combine those roots, and I end up with a to the power 5, b to the power 6, and then combining those roots, I end up with a 1/6 root. Okay, so cube root and a square root together is the same as a 6th root. And then I can apply our power. So I'm just going to highlight this here. So those two together give us that. And so we end up with a to the 5/6 and b power 6, root 6 undo each other, so we're just left with b. We can do it as b to the power 1, but I'm just going to leave that as b. So here I want you to just notice a couple things. This layering these roots is actually just combining these roots becomes a 6th root. The other thing here I want you to just notice is when we ended up with a cube root and a square root, we can actually work these together if we end up with a common index or common sixth root here. So cube root and square root has a common root of sixth root. And that's our common denominator. It shows up as a common denominator when we end up having to add these fractions together. So this 1/2, this denominator 2 came from here, square root. This denominator 3 came from here, cube root. And we were able to apply exponent rules if we got a common denominator. And that means that if we had a common index up here, we would have been able to also combine those roots together as roots.